Hi, in this video, we are going to look at a couple of problems for JEE Advanced. This is the first one. This is a calculus problem. Let's look at it. F is a function defined from 1 to infinity to r, and it's a differentiable function such that f of 1 is 1 by 3. And we have this relation, 3 times integral of 1 to x f of t dt is equal to x square f of x minus x cubed by 3. We have to find the value of 3 times f of e square, right? So when we look at this problem, obviously we have to analyze this condition. And since it's an integral over 1 over x, we should apply Newton-Leibniz formula and differentiate this. So differentiating both sides of this expression with respect to x, what we'll get is 3 times f of x times derivative of x minus f of 1 times derivative of 1, which is 0. So that is equal to the right hand side derivative is 2x f of x plus x square f dash x minus 3 times x square by 3. So that is x square. So this becomes basically 3 f of x is equal to 2x f of x plus x square f dash x minus x square, right? Correct. So if I bring everything to one side, I have made a mistake in stating the question. I think here there was a t as well. There was a t here. So if there is a t here, this will be x f of x. So this becomes x times 3 times f of x. So finally what you get from here, this can be taken to the other side. You get x f of x is equal to x square f dash x plus minus x square, right? Now this condition, how do we use this? So we bring everything on one side. So you'll get x square f dash x is equal to x f of x plus x square. And this is like saying x square df by dx is equal to x f plus x square. And we can rearrange it like this. Df by dx is equal to 1 over x f plus 1. And we can write it as df by dx minus 1 over x f equal to 1. So this is my linear differential equation of first order. Linear DE of first order. So the way to solve it is using the integrating factor method. So in this case, integrating factor is e power integral of p of x dx. And what is our p of x here? P of x is this function. So it is e power integral of minus 1 by x dx. So which is e power minus ln x, which is e power ln 1 by x, which is 1 by x. And the solution of the differential equation is f times if, which is 1 by x, is equal to integral of q times if. So 1 times 1 by x dx. So this becomes basically f of x by x is equal to ln x plus c, right? This is what we are getting. Now, we will use the initial conditions that were provided in the problem. In the question, they had said that f of 1 was 1 over 3, right? So if we put x is equal to 1 here in this relation, we will get basically f of 1 by 1 is equal to ln 1 plus c. ln 1 is 0, so c is equal to f of 1, so is equal to 1 over 3. So my solution finally becomes f of x by x is equal to ln x plus 1 by 3. So f of x is equal to x ln x plus x by 3, right? And now we just have to find f of e square and multiply it by 3. 3 times f of e square. So that will be 3 times e square ln e square plus e square by 3. And ln e square is 2. So this becomes 3 times 2e square plus e square by 3. So that is 7e square by 3. So answer is 7e square. So a pretty straightforward question which helps us uh, figure out the value of the function by using Newton-Leibniz formula and differential equations. Let's look at the next problem. Question 2. It says, let A1, A2 till A10, A12 be a regular dodecagon. A dodecagon is a 12-gon. So it is a 12-sided regular polygon, right? That lies on a circle with center 0, 0, with center 0, 0 and radius 5. Let P be a point on the circle. Let P be a point on this circle, and PAI denote the distance between the points P and AI. The distance between P and AI, where I goes from 1 to 12, right? We have to find the maximum possible value, the maximum possible value of the product I goes from 1 to 12, PAI, and we have to multiply this with, okay, we can just find the maximum possible value of this product. Yeah. So the point is, this is an application of the complex number idea of nth roots of unity. So if you recall, if I have an equation like this, x power n equals 1, all the roots of unity are lying on this circle of unit radius, and this forms a regular polygon of n sides, right? This is standard theory. There are n vertices on this circle. This forms a regular polygon of n side, and we will have an angle subtended at the center will be basically 2 pi by n and so on. This is a regular polygon. Now this time the circle is radius 5. So we cannot have an equation like this. We will have an equation x power 12 is equal to 5 power 12. X power 12 is equal to 5 power 12 will have basically 12 roots. One of the roots is 5. The other roots are 5, 5 e power I 2 pi by 12. Then the next one will be 5 e power I 4 pi by 12 and so on, right? Because our n is 12 and you have 2k pi by 12 where k goes from 0 to n minus 1. So finally you'll have 5 e power I 2 pi n minus 1, or which is 12 minus 1 in this case, 11 pi by 12. These are our roots, right? So what I will do is I will try to write x power 12 minus 5 power 12 equal to 0, this equation, as the product of the factors. And each factor will give us one root. So there should be 12 factors here. It will be written as x minus 5, x minus alpha square, till x minus alpha power 11 equals 0, where alpha stands for one of the complex roots, the basic complex roots, which is e power 5 e power I 2 pi by 12, right? Correct. So these will be my roots. Now, if you do square of this alpha square, you will get the next root, right? No, I am making a mistake because the modulus will also be squared then. So what we will do is, okay, so we will not write it like this. What we will say is, we can convert this equation as x power 12 is equal to 5 power 12. We will say x by 5 power 12 equals 1, right? And we'll take a new variable of x by 5 as y, right? If you take x by 5 as y, this equation is y power 12 minus 1, which can be written as y minus 1, y minus alpha square till y minus alpha power 11. And now alpha can be written as e power I 2 pi by 12, right? And alpha is basically y, which is y is x by 5. So finally x will be 5 times this, right? Now what do I need to find out? I need to find out the distance of a point P from any of these roots, right? I want to find the product of distances. So if you think about it, on the circle, 5 e power I theta lies on the circle, with center 0, 0 and radius 5, right? 5 e power I theta is a random point here P. It lies on the circle. What we need is the distance of this point from all of the roots, right? We need this chord length, we need this chord length, we need this chord length, and similarly the product of the distances of all the chord lengths, right? Okay, so if I put y as 5 e power I theta in this equation, what I get is basically 5 power 12 e power I 12 theta minus 1 is equal to 5 e I theta minus 1, 5 e I theta minus alpha, 5 e I theta minus alpha square, and so on, right? So I am putting y is equal to 5 e I theta in this curve because basically this point also satisfies the condition that y power 12 will be equal to 1, right? Once we put it in this, what we'll do is we'll take modulus on both sides. So we have 5 power 12 e power I 12 theta minus 1 is equal to 5 e I theta minus 1, 5 e I theta minus alpha, and so on till 5 e I theta minus alpha power 11. These will be your distances of this point P to the point A1. This is PA2. It would be distance if you had taken mods, right? So we will just take mods on both sides. So modulus of 5 power 12 e power I 12 theta minus 1 is equal to PA1 times PA2 till PA11. This is the product of the distances. Now you just have to calculate the modulus of this, and this is 5 power 12 and modulus of EI 12 theta minus 1. If you convert this complex number to Euler form, basically you'll have to write it as cos 12 theta minus 1 plus I sine 12 theta. And cos 12 theta minus 1 can be written as minus 2 sine square 6 theta. Plus this can be written as 2I sine 6 theta cos 6 theta. So obviously 2 sine 6 theta can be taken as common, and you can even take this minus can be written as I square, and you can take I also common. So you'll get cos 6 theta plus I sine 6 theta. 2I sine 6 theta is outside, and inside you get this. So when you take modulus, the inside part has modulus 1. So the modulus of this will be simply 2 sine 6 theta, right? So what we get here is 5 power 12 into 2 sine 6 theta is basically the equal to the length of the product of these lengths, right? So finally we can say that the product of these lengths, product I goes from 1 to 12, PAI is equal to 2 into 5 power 12 sine 6 theta. So it is less than equal to 2 into 5 power 12 because sine 6 theta can take a maximum value of 1. And that becomes our answer here. Okay, that is the maximum value of this product. The next question that we look at is this one. For x belonging to R, let mod of 2 tan x tan inverse x is less than pi. Find the minimum value minimum value of f of x is equal to integral of 0 to x tan inverse x. And here you have e power t minus cos of t divided by 1 plus t square till t power 2023 dt. We have to find the minimum value of this. Now this condition basically is just saying that tan inverse x, the modulus of tan inverse x is less than pi by 2, which is anyway true because the tan inverse x modulo is less than pi by 2. So this is true because the range of tan inverse x is anyway from minus pi by 2 to pi by 2. This just tells us that tan inverse x cannot take the endpoint values of pi by 2 and minus pi by 2, right? Okay. Now, how do you find maxima minima? You'll have to take a derivative. So if you take a derivative here, f dash x, we are technically doing d by dx of f of x. So since this function is a function of t and the limits are in x, so dy dx has to be done using Newton-Leibniz formula. So what you will get is, put this thing in place of t everywhere. So you'll get e power x tan inverse x minus cos of x tan inverse x divided by 1 plus x tan inverse x plus x tan inverse x whole square till x tan inverse x whole to the power 2023, and then you have to multiply by the derivative of x tan inverse x, which is basically equal to tan inverse x plus x by 1 plus x square, right? So this whole expression is my derivative. Now think about it. In order to find maxima minima, I have to understand what is the point where the derivative becomes 0 and what are the points where the derivative changes sign, right? You can see that this numerator can never be 0 because e power something cannot be 0. Also the denominator, you have to realize that x times tan inverse x is always positive. Why? Because if x is positive, tan inverse x is positive, and both will be positive. But if x is negative, tan inverse x is also negative. So it is an even function, x tan inverse x. So it is always positive. So the denominator is always positive. This part is always positive. So only way in which f dash x can be 0 is if this is 0. And this is 0 only if x is 0. X is 0 is a valid point where this becomes 0. If x is positive, the whole thing is positive. If x is negative, the whole thing is negative, right? So basically the sign of the function f dash x, sign of f dash x clearly depends only on this part because the rest of the stuff is anyway positive for all x, right? So that means that f dash x is greater than 0 for x greater than 0 and f dash x is less than 0 for x less than 0. So what kind of a function would f of x be if the derivative is negative and then changes sign and becomes positive after 0? That means fx has a minimum value at x is equal to 0, right? And you can see that the minimum value of fx would be, if you put x is equal to 0, the integral itself vanishes. So the minimum value of this function is simply 0. So even though the question looks very complicated, you actually don't have to do anything about this part. You just have to think critically after taking derivative. After you have taken derivative, you have to think carefully and figure out what is going on about the maximum minimum for this function. Right. One last problem that I will look at in today's session is this one. You have function defined from 0 to 1 minus 1 by 3 to r, and the function is defined like this: f of x is equal to 4x GIF x minus 1 minus GIF of x by 3 whole to the power GIF of 2x and x minus GIF of 2x plus 1 by 4 whole to the power 3 plus GIF of x. We have to figure out the continuity and differentiability of this function at all points of its domain. Its domain is basically interval from 0 to 1 except the point 1 by 3, right? So 1 by 3 is not allowed, and that is my domain here, right? So how do we figure out continuity and differentiability? The thing to realize is that the mod 4x will keep changing its behavior. Mod 4x, mod x, mod 2x. They will keep changing their behavior. So what we need to do is to understand which are the points at which mod of 4x will change its nature. And we have to define the function in a piecewise manner. So what I can say is 4x will be an integer when x is 0, x is 1 by 4, 2 by 4, and 3 by 4, right? And after that it becomes x is 1, but 1 is not allowed because 1 is not in our domain. So these are the 4 points I will consider. So let's look at the case where x is less than 1 by 4 and between 0 and 1 by 4. F of x would be simply 0 because 4x GIF would be 0 and it is a product of these factors. So f of x is 0 when x is between this range. Now what happens when x is from 1 by 4 to 2 by 4? But it is less than 2 by 4. So if x is less than 2 by 4 but greater than 1 by 4, in that case GIF of 4x will be 1. GIF of 2x would be 0, right? And GIF of x is anyway 0, right? So in this case, when you write the function, this part becomes 1. You have 1 times GIF of x is 0. So you have x minus 1 by 3 whole power GIF of 2x, which is 0. And then you have x minus GIF of 2x is 0. So x minus 1 by 4 whole power 3 plus 0. So the function in this case is becoming x minus 1 by 4 power 3. That is the function when x goes from 1 by 4 to 2 by 4, right? Similarly, we will analyze the cases when x is greater than 2 by 4 but between less than 3 by 4. So 1 by 4 or 2 by 4 is less than x, less than 3 by 4. In this case, GIF of 4x is still basically going to be 2. Let's write what is all the GIFs in this case. GIF of 4x would be 2. GIF of 2x 2x would be 1, right? And GIF of x would be 0. So now putting all this data in the definition of the function, we will get twice of x minus GIF of x is 0. So it is x minus 1 by 3 whole to the power GIF of 2x, so which is 1. And then you get x minus GIF of 2x is 1 plus 1. So it is minus half 3 plus 2 or 3. This is the nature of the function in this range. And finally, you get 3 by 4 is less than equal to x is less than 1. And in this case, similarly, the function definition comes out to be 3 times x minus 1 by 3 and x minus half power 3, right? Correct. X minus half power 3. Why? Because this term will become x minus GIF of 2x is 2x is between 3 by 2 and 2. So GIF is 1. So 1 plus 1, it is x minus half whole power 3 plus GIF of x is still 0. Correct. So these are my 4 piecewise defined functions. This is this one, and these ones, right? So now I only have to check at all of the points where the function changes its behavior. So let's check at half, or let's check at 1 by 4 first. Notice that the left hand side value is 0, right hand side value is also 0, and value of the function is 0. So it is continuous at 1 by 4. Now let's check continuity at 2 by 4. From the left hand side, when you put 2 by 4, you have to put it in this function. It will become 1 by 4 power cube, so 1 by 64. And from the right hand side, when you put 2 by 4, you will have to put it here, because half minus 1 by 3 is 1 by 6. And this part is 0 because you put 2 by 4, you'll get 0 here, right? So it is left hand limit and right hand limit are not matching. So 2 by 4 or x is equal to half is a point of discontinuity. Similarly, let's check 3 by 4. So when you put 3 by 4, you'll put from the left hand side, you'll put here. So 3 by 4 minus 1 by 3. So that becomes 4 by 12 and 3 by 4 is 9 by 12. So 5 by 12. So it is coming as 2 into 5 by 12 and 3 by 4 minus 2 by 4. So 1 by 4. So 1 by 64. So we are getting 5 by 64 into 6. And from the other side, when you put 3 by 4, you get 3 times 3 by 4 minus 1 by 3. That is again 5 by 12. But this time you have 3 by 4 minus 1 by. Okay. So the problem is that this time it is 3 times 5 by 12 into 1 by 64, which is different from 2 times 5 by 12 into 1 by 64. So again, 3 by 4 is a point of discontinuity. So since these two are points of discontinuity, obviously, they will also be points of non-differentiability, right? Any point where a function is discontinuous, it could also be non-differentiable. However, we also have to check other points for non-differentiability because you could have a continuous function which is still non-differentiable. So you should check the other points as well. 1 by 4 and yeah, that's the other point that was left. 1 by 4. You should check 1 by 4 for derivatives and seeing whether it is having a derivative or not. So from the left hand side, derivative is 0. From the right hand side, it will be 3 times x minus 1 by 4 whole square. Again 0. So it is differentiable at 1 by 4. So far what I have gotten is 2 points of non-differentiability and discontinuity, which are 1 by 2 and 3 by 4. So that's the solution for this particular problem. We'll continue with to discuss more problems in this series. Like tomorrow, hopefully I'll bring you another video with more practice problems. By the way, in case you didn't know, the courses for Maths Olympiad 2025 have been announced. You can join the WhatsApp group and register for the course. The course starts on 13th of March, which is next Wednesday. And I'll be accepting around 20 students max. After that, there will be a new batch for later. So right now, I have already shared the problem sets for the entire Olympiad course on the YouTube video as a Google Drive link. So you can already look through the problem sets and start working on them. We'll be discussing all of the questions in those problem sets in the class. Also, the new course for JEE Maths next year's JEE, which is JEE 2025, and for JEE 2026 is also going to be launched. I will be sharing a video about that soon, today or tomorrow. And registrations for that will also open now. So the point is that the JEE course will start around March 11th for the people who are writing JEE next year. And again, it will be live courses, live classes, 3 classes per week. And we'll be starting from 12th standard topics for students who are writing JEE next year. So please be aware of that. And once I post the video and the WhatsApp link, you can join the WhatsApp group and you can register for the course right away. So I'll see you then. Hopefully you've got something from the video. Please like the channel, subscribe to the channel as well, and continue to provide your support to the channel. Like that's how I bring my content because of you guys who are demanding more and who are supporting me. Thanks a lot. I'll see you next time.